Dr. Dean Boyd, owner of Animal Nutrition Research, LLC, is the architect of the paradigm shifts regarding the use of soybean meal in swine diets. His presentation is titled, "4 Pillars of Soybean Meal's Unique Value to Swine Nutrition and Health." Dean?
Well, thank you very much, David, and thank you, Emeritus Professor and President of the University of Illinois. What a blessing that is to have Robert Easter with us. Those who are young and haven't had a chance, you should meet with him. He's a truly wonderful man. Ladies and gentlemen, today we're celebrating, and you're about to celebrate, my 50th year to the month since I presented an abstract to animal science meetings. We did it in Iowa State University. Most of the people there that attended are dead. I'm one of the survivors. So I told this society goodbye 8 years ago. I wouldn't be back, and so here I am. So I spent a lot of time working with James Usry, who's quite a mastermind, to be frank about it, of asking the right questions and picking the right designs in promoting the use of synthetic amino acids. And my need to do that was not selfish, but as the pigs were becoming leaner, the amount of soybean meal that was needed was extraordinary. And it was also so high that the carcass yield of the pig went down. But I will tell you what happened when DDGs came to market was that combined with the 4 amino acids, 2 of which we'd helped to bring forward, caused soybean to drop in the diet to levels I hadn't seen, even in the early 70s. So when it came time for us to have high growth rates, that combination, for whatever reason, wasn't working. And we compared it to the corn-soy diet to get our minds around it, and we were stunned. So this session 1 is really a report by a strategic committee that of swine nutritionists, veterinarians, and muscle meat biologists that was commissioned by Dr. Keenan McRoberts and Susie Sutton-Vermillion. Yeah, the top left was assigned to regulate us, guide us, and I learned from her the new word voluntold. And I can't say enough about her, but the conversations that we had from Honor with Keenan was that although we had some information that was holy sanctum, there was information that could be unearthed and brought into the public sector. And so this committee was appointed to help me in data mining. On the bottom left, Steve Pullman was president of Murphy Brown Western Operations. Bart Borg, a lovely man in the middle, was part of his team. We have Paul Yeske and other heavyweights. Now, we have put together a series of documents and have used feedstuffs as the vehicle. That's my new favorite journal, by the way. Now, I'm an older fellow, and I published in 22 peer-reviewed journals. So I've been down that road, but I didn't want to write articles that could be immediately considered and at least partially supplied and have 45 downloads in a year. So Feedstuffs was a vehicle to get it distributed across the earth and into the right hands. However, the United Soybean Board and members or administrators such as Keenan and Jennifer Garrett didn't want us to publish stuff that couldn't stand significant scrutiny. And so we did so. And we produced these 10 articles plus a capstone 11 in a book. The book sells for free. It's in the back, and you're invited to take it. So again, this was edited by Jennifer Garrett and David Holtzgrafe. If you open the thing to take a look at the content, you'll find that there are 11 articles and then an additional page about frequently asked questions in the future, near future. But the most innovative part of this, and I've only captured 4 of them, of the articles, is a QR code. If you hit the QR code, that will allow you to access the reprint. The reprint can be downloaded, and the reprint has the DOI, so you can cite it. Now, in the course of this, there were not less than 19 co-author scientists that have given input into this, some academic realm, most, in fact, in the private sector. But there are 19 of these. You'll see Richard Ostick is toward the bottom on the left. Richard's an expert in amino acid nutrition in the poultry area, and also we point out to you that there were 10 subject matter scientists, and they're listed in the book as well, plus where they made their contributions. And the procedure for review, we'll say peer review, are carefully outlined. I think of the journals I published in over the years, biology of lactation maybe was the hardest. But this was harder than all of them. But the nice thing was, this is a friendly crowd, and their interest was to help me if I was helpable, but to improve it and make certain that the rigor was there. The tact I'm going to take is similar to Stephen Hawking, who passed away a few years ago, where he wrote about the universe in a nutshell. So I thought that's good. I thought I would characterize the new knowledge that we were able to unearth in a nutshell. I'm going to be taking that from the final paper. It's called the capstone paper, and that distills some of the most consequential findings that this study team had of the Henor information. Now, one thing that was vital to teasing out some unique aspects is that much of this work was done in a commercial environment. So you have stresses that wouldn't be available in the academic environment. We operated in both. But were it not for the commercial environment, we wouldn't have been able to detect some of the unique features. As we looked at the information and studied it, there were 4 distinct categories of advances that we brought forward. Now, we've worked on this for 3 years, and you've heard about some of these, but I'll distill them together. The first pillar is the energetic value. We wanted to make sure and get that right. We had no interest in just padding soybeans. We're interested in scientists and in science. And so we found some things very interesting there. And in the process, maybe made some people mad. I'm 75, I don't really care. So at any rate, the second thing was a surprise to me. And that is that if one wanted maximum growth and feed conversion, you had to have a certain level of soybean meal. And I can't tell you why, but I will give you a gentle hypothesis. The third is it's a historic one about the soybean, a legume, which like other legumes has an abundance of functional compounds, is very good at fighting certain kinds of diseases and inflammation. And we made a stunning find. And then finally, a very expensive thing, the mitigation of the carcass dip. If you're going to make profit, oftentimes it will be in the summer, but not always. And that brings us to the Bart Borg, David Rosero part, to try and project when I'm going to use more soybean or when I'll deliberately use less. Advancement 1, the energetic value. Now, I will tell you straight out, Cargill is expert in this, and since the late 90s, I've worked with him to compare. And like Purina in the mid 80s, that was trying to validate raw stock information. That group was early predicting net energies. We compared soybean, which is the second blue bar, Boyd and Rush 2018. That's when we published it, but the growth assay conducted in an academic-like environment. We were deliberate about that because that's the only place we could do it at the time. But we later realized the importance. We came up with nearly 2,500 units on a dry matter basis. That's about 82% of the NRC corn. And when we compared it to corn, we always carefully scrutinized the corn that was being displaced by the soybean. In the red bar, you see what's really the gold standard for energy, and that is the indirect calorimeter. What was unsettling is later, we looked at the relative energy value of soybean while the pigs were in a commercial environment. It was the eve of 2010, the night before I was to provide the abstract. James Usry had financed it. We had planned to put a black mark on soy using science, and my bias was too deep, and I said it was 78% of corn, but the night before I gave the abstract, I said, oh my goodness, it's 109% of corn. So I had to skip James Usry's dinner that night, and my talk the next day was a very short talk, very cordial, very short. And we couldn't figure out why that was the case. We threw the data away electronically. 2010. So considering this, what we'll now call productive energy, and this is where I carefully sought John Patient's advice for how to define this term and not have it mixed up with net energy, not used terms used interchangeably. So in the middle curve or the middle bar under the academic setting, we had nearly 2,500 units. So if one assumed that for the right side, which was commercial, we said there's something around 810 extra units of energy for soybean. It seemed inconceivable that could be due to soybean, that was was in the soybean. We eventually decided it's probably that something in the soybean was causing a slightly greater use of the total dietary energy. And we had thought seriously about what Dustin Kendall said maybe 15 years ago, what I consider to be a classic paper on bringing new technologies forward. He said, sometimes don't come to me unless you have substantial evidence of what it does. But when you come to me, I will hope you will also, even though you can't explain the rationale, might you have a hypothesis that you think is reasonable and that is testable. Now, I depend on stuff from Martin Iacciati, Nicole Huntley, and several who work together, who help me form an opinion on this. So we had defined this productive energy as a Venn diagram that had a net energy sector that was huge, but it had this other stuff. How could that be? In the left side, Martin and the team, using calorimetry, showed that in the academic setting, that the amount of net energy used for maintenance was fairly predictable. However, they then challenged the animals with several things. One was an unsanitary environment. And they had a couple iterations of challenge, and it showed the flexibility of NEM, since that's where the data dumps, that in a commercial-like facility, the NEM would be greater. It became, and is still, our proposal that because of some of the functional components, non-nutritive, that are in soybean, that could reduce inflammation, could increase viral clearance, et cetera, that the body is having to come forward with less energy spent on protective mechanisms. And so a constrained NEM is how we proposed. This might be, and it's also very testable, should be a research priority. The second advancement was kind of an interesting one. I simply state that soybean is vital for growth. It's vital for maximum growth expression, but if you try to go with a soyless diet, you'll get impaired growth. And I mean the composition of the animal changes. So I want to refer you to the fifth paper that I call the foundation paper. This was conceived by James Usry, conducted by Mike Johnston. When he does stuff, there's no need to chemically assess things. It's going to be exact if you had things right up front, but we did. Dick Ostick was involved in this, David Baker and Benavinga both reviewed it in '99 when we presented it, so we could get their opinions. And we had a paper, internal research memo at that time. But with time, trustworthy net energy values came forward for ingredients and the 15 amino acids that we used in this study. So let me show you. In the far left, for the pigs we were talking about, they're about 60 kilograms going to 90 kilograms. The adequate diet for the time was 0.81 true ill digestible, and that diet was 17% crude protein. Now, we reduced the crude protein and the lysine level to a point where it's on the verge of becoming deficient, or maybe slightly deficient. And that became our base diet. And so the lipid level is in the blue, the protein's in the red, and I like to say thank you to Floyd McKeith and Mike Ellis for grinding these pigs. I didn't want anything to do with it. I did it, didn't like it, so I said, would you please do it for me? And they were fine with it. Just said, bring your checkbook. So at any rate, the pig deposition at that point was 188 parts lipid to 1 part protein deposition. With the 15% diet, 0.64 lysine, you had a gentle numerical increase of 218. Now, as we took that 15% diet and reduced the protein to 13 and then next to 11, that was taking us down from 15 to 11, 4 points. But the amount of soy that we dropped down or nearly out, all of the essential amino acids were placed back in. The non-essential amino nitrogen was returned. And the conditional essential amino acids, tyrosine and cysteine, were replaced. So these diets were exactly the same in amino acid composition, but the soybean and protein level was different. And you can see in the right side the amino acids that we used. James Usry spent about $25,000 at that point to help us to get this done. Well, at that time, and I'm not trying to be braggadocious, but there was no peer information. David Baker and Norland Benavinga both indicated that. Benavinga had information like that in the rat. But I think the data, it was relevant then because James wanted to know when might we, as we expand the library, get to a point where we run into a problem, or will we run into a problem? He wanted to know that. That's how far-reaching his mind was. Well, so let me just paint a picture. That's what I'm going to try to do now. And in the left, you have a control diet that we can get by with. It has plant proteins in it. Soybean, it has essential amino acids and performs very well. We'll call it the control diet. The second bar in is what we just tried to do. We said we will drop down to a very low soybean diet. It was about 50 pounds of soybean per ton. We'll add back every amino acid that we lost and take care of that, and then we'll assess where we're at in energy, net energy, when that data becomes available. We published this in my favorite journal, Feedstuffs, in 2024. Now, the third bar in is a very important piece. We said it's not amino acids of any kind, and we have the net energy, so we know there's only a gentle disparity. So could it be the protein component? So we used and this is not published. I kind of exhausted myself. But we took the soybean protein down, and we replaced the soybean protein with isolated soy protein, which is 90% on a dry matter basis. The difference between soybean and that was that the isolated soy has a tremendous loss of the functionals. For example, isoflavones, whereas they're only to the extent of 10 or 20%. And I used human-grade material. I got the same result. I was actually surprised. And so I'm coming now back to Johann, of a 1993 version of Johann, and David Baker, who said, and I'm not sure how they came up with it at that point, but maybe if we replace the soybean with something like casein, and you could have also done with whey protein, you could have done it with a combination. Those two components have biological functions, and those of you who have done studies in the commercial sector know with Aaron James's product with the FXP that one of the things it does is to actually improve viability of the pigs. And Joe didn't have quite enough animals, but it did show us that if there was a chance of replacing, that it would have to be something probably with biological activity. The second thing, this was a two-sided coin. And so we concluded that as far as the advances, at some point, and the removal of soybean meal as something other than amino acids, and now crude protein was becoming first limiting to growth. We also found, though, with soybean, something that always happened. Whenever I take a corn soybean diet and I put synthetics are doing great. Love synthetics. But the diet that always grew the best and feed conversion was best was in a corn soy diet. Not practical, too expensive to feed, but I could never get that out of my mind. It was always the best. So I simply want to show you something that was a breakthrough by Eric Van Houten. He showed in their work at NC State that the level of growth, and these are pigs that are 100 and I think 83 pounds to start with, growing up into the mid-270s, that the rate at which they grew or the amount of pounds they accumulated depended on the amount of soy in the diet. And that was kind of a surprise. He did things in a way that it was very clean. You didn't have a lot of things moving. And so we took a lesson from it, and we looked at studies that we had for how much synthetic lysine could we use, flipped it over, how much synthetic lysine that we could use meant we were changing only the level of soybean meal, corn, and synthetic amino acids. And from 24 pounds of the last diet in the nursery to nearly 300 pounds, you can see that as we increased soybean in the diet, we got what Eric showed for 2 phases, and both with gain and feed conversion. We got a response. And we never thought about it until we saw his stuff, which is paper 6. Now, I'm showing you in this slide, this is a theoretical curve. I accidentally copied in the wrong one. The one in the book and paper 10 is the right one. But we did this titration from all phases. The pig can't take advantage of as much, and the 4th diet is still acclimating. And Nathan Augsburger was very helpful. The level of soybean in each phase that will maximize growth when you need growth to be maximized is shown here. It's a little stiff to think about, but that's it. The advancement 3 is an important one on soybean reducing, mitigating the horrible effect of PRRS virus. Some would say it's probably amino acids or protein, but I can tell you because of the left curve, it's not crude protein difference. Those are exactly the same. It's something other than amino acids or protein. That's the big deal. And in the capstone paper, we show some of the studies that were done since, to a great extent out of the Dilger lab, a little bit by JBS and New Horizon, and the K-State people. Some wonderful stuff that's come forward to show that isoflavones, possibly saponins, are a big deal when it comes to disease. The summer heat stress, won't say much about it because David will cover it, but there's no sense in having it. If you want to get rid of the carcass dip, it's easy to do. If you want to do least cost diets all your life, you'll always have a carcass dip. And the basic reasons are 4. The soybean level has to be at a level to maximize growth. And the second is that the most important obstacle to your growth when you need the most rapid growth is DDG levels at 10% or above. It doesn't matter what you do. If they're in there, it undermines it, you're dead. The third is you have to adhere to maximum synthetic lysine levels. They're shown. Aaron and I have known this for 100 years or so, and that's in paper 7. If you're putting 10, 11 pounds in a diet for 220-pound pig, it's not the best thing to do profitably, but it may sell you more feed if invoice is the basis. So what we did with Eric Van Houten's data is to show that in the solid curve, as you increased soybean meal, that the amount of pounds gained increased. But in the dash curve, if you fed those same levels of soy but had a base of 20% DDGs in these diets for 183, 275-pound pigs, it was devastating. And you couldn't add enough soybean, you couldn't add enough fat to get rid of it. Well, I want to basically conclude here. And that is that undergirding these 4 pillars of new information and on the heat stuff, that was downloaded by David Rosero and Amanda Ellsburn into our hands. That undergirding all of this, there's a unifying hypothesis and a term that was applied by David Holtzgravy that I didn't give thought to. And the thing is that I can feed diets that are equal nitrogen, equal amino acids, and every other nutrient, but the diet with higher soybean meal will perform better. If you have diseased, respiratory disease pigs, and the reason PRRS is a big deal, it doesn't come like flu 3 weeks in and then out. It lingers much longer. And it also harms viability. Well, we've seen those extraordinary things. And so the unifying hypothesis was this, is that because soybean and other legumes have about an abundance of functional components in them that are growth promoting, disease fighting, inflammation fighting, etc., that these components may complement the efficient use of amino acids for growth. In this case, in the brown bar, net energy was the same for all diets as we increased amino acids. But eventually, after 6 pounds of synthetic lysine, the feed conversion, the dots, began to stray. That was news to net energy. Things looked good. However, using productive energy, you can see on the left, the lighter brown bar, as we had plenty of soy, the productive energy was high. As we moved, soy came down, productive energy went down, and they may be related, may not be, but when soybean productive energy got to a certain point, then feed conversion departed. So I'm going to leave that. Here's a beautiful picture of Bart. And Aaron, start your talk off by telling about this, Bart. We collaborated with AMVC. This isn't complete unless you have 100,000 pigs under it. And so we did that, but the bottom line for us is we simply let the pigs do the talking, and we did their best we could to implement. And boy, I got surprised some way. And I'm not comfortable with not being able to delete soy and have the pig get fatter. You overeat and get fatter. It makes me worried. Why would you have to have soy? When we selected the pig for 60 years with a soy base. So David, in that sense, I'm going to say thank you very much, and I hope I never come back. Okay.
Thank you, Dean.